calculator portion because there's a lot of like little things you have to know how to put it in your calculator, and I'm not helping you tomorrow. Okay, you have to know how to do all this on your own. So the first thing I'm going to tell you is that 1 through 3 are your non-calculator problems. Okay, those are the only ones. They're going to be the last 3 problems you do. So when you come in tomorrow, you'll get your answer sheet, which is going to be numbered 1 through 9 for the multiple choice, and then the FRQs on the back. And you're going to start with number 4. Okay, so tomorrow's test starts with number 4. You'll do all of your multiple choices with the calculator 4 through 9. Then you'll do your FRQ. Then you'll turn that into me, and I'll give you the non-calculator, which is just the 3 questions. So you're really starting with number 4 tomorrow. So that'll make more sense tomorrow, but I just wanted you to not be like, what's going on? You know, you want to use all the time for the test. So, but I'm going to start at 1, 2, and 3 for the purpose of going over the review. All right, so the first question, just hit in. No one? One not there? Zach, is one sitting next to you? Thank you. Okay, and I'm making a video of this too, so if you missed something or you just want to go over it again, you can. All right, so the very first question is, determine which of the following is a vertical asymptote of this graph, so asymptote. So the way we find asymptotes for tan and cotan is we take our argument and we place it right in between the parent function's asymptotes. That's something you have to know ahead of time. Tan has asymptotes at negative pi over 2 and pi over 2. Cotan, his friend, has asymptotes at 0 and pi. You need to know that. Your first question is either going to be tan or cotan. And so you do the same process, it's just what you put on either side that will change depending on if it's tan or cotan. So in this case, it's tan, so I'm going to put negative pi over 2 and pi over 2. And I'm going to solve for x. So the first step would be to add pi over 3 to the sides. So add pi over 3 here, I'm going to add pi over 3 over here, and I'm going to add pi over 3 over here. 3. Okay, so in the middle, we still just have a 2 and an x, right? So pi over 3 is canceled. And I need a common denominator for 2 and 3 on both sides without a calculator. So that would be 6. 2 times 3 gives me 6, so I multiply the pi times 3. 3 times 2 is 6. 2 times pi is 2 pi, which gets me 5 pi over 6. Same thing over here. 6 would be my common denominator for 3 and 2. Multiply 3 by 2, multiply the numerator by 2. 2 times 3, negative pi times 3. And so we have to be able to work with fractions without a calculator. We do it all the time anymore, so hopefully you guys are getting more comfortable with it. And that's 2 pi plus, I didn't mean to put double negative, so plus negative 3 pi would be negative pi. And we still have to get the x by itself, so I would divide by 2, right? Divide by 2. Now, I can divide both of these by 2, but that will end up being keep, change, flip anyway. So instead of dividing by 2, I can multiply by its reciprocal, which is 1/2. That's the flip part. Keep the numerator, change division to times, multiply by the reciprocal. So dividing by 2 is the same thing as multiplying by 1/2. And we get negative pi over 12 and 5 pi over 12. Those are the two asymptotes if I were graphing them. The only one that's an option here is the C. So that one is an asymptote. Where? 1/2? Dividing by 2 is the same as multiplying by 1/2. Does that make sense? Okay. If someone still doesn't understand that, when I'm done, if there's extra time, ask me and I can go over that with you. But we've talked about that quite a bit. Or if you don't understand that, just divide by 2, and then you have to do the keep, change, flip. Just adds a few steps, but you end up multiplying by 1/2 anyway. All right, next one. For what numbers x on this interval of the x-axis is the graph of secant undefined? So first thing I know is that secant is the graph of cosine, his friend, and then I do those asymptotes on the x-axis, on any of my x-intercepts, and then I have those maxes and min looking u's. And undefined, that's your asymptotes. So where are the asymptotes on this graph? So for me, it's easiest to sketch the graph. That's what I'm going to do, right? So I'm from negative 2 pi to 2 pi. And so the period of cosine is 2 pi. So from 0 to 2 pi, I would have my 5 points. And cosine, again, is up, middle, down, middle, up, right? Up, middle, down, middle, up. Everywhere you have a x-intercept, you're going to have a asymptote, which is where the graph of secant is undefined. So now all we have to do is say, like, notice I didn't spend a bunch of time drawing the whole graph. I didn't make the curves. I didn't do the U-looking things. All I care about are the asymptotes. So the question is, what are those x values? Well, remember, if you're graphing from 0 to 2 pi and you're making 5 points, these are just your quadrantals. This is 0. Right in the middle would be pi, and then the last one is 2 pi. What's in the middle of 0 and pi? Pi over 2. Then there's pi. Then there's 3 pi over 2. And it's the same thing on the other side, just the negatives. And that would be that. Yep. I can't hear you. Couldn't you tell by what? I don't, you would know by the negative 2 pi. Wait, can you just, meaning that's how you would know the other two? Yeah, however you don't have to show work. I'm just giving you guys all that I can give you. If you can find a shortcut somewhere, do it a different way, do it in your head, memorize, it doesn't matter to me. So yeah, you don't have to graph all of that. You figure out how you answer the question. I'm just giving you every bit of information I can offer to you, okay? All right, next one is, what are all the values of theta on the unit circle? That's what that means. And here's the equation. Solving an equation, guys. 2 cosine squared theta equals cosine theta. We have to solve it. So we did a whole day of all these different types of factoring with words, and this is where you want to get everybody on one side together and factor out the GCF. So I would have 2 cosine squared theta minus cosine theta equals 0. I just subtracted cosine to the other side. And I can see that these guys have cosine in common, right? They both have a cosine. That's my GCF, cosine theta. Whatever's left over goes in the parentheses. So remember, all you're doing is dividing both terms by that GCF of cosine theta. Whatever's left over, as I said, is right in the parentheses. So remember what cosine squared means. It means 2 cosines. It's 2 cosine cosine. Just write it as cosine squared. So we can cancel this cosine with one of those, right? Instead of 2 cosines on top, we just have 1. So that's 2 cosine minus cosine divided by cosine is 1. It's factored. Once we factor something, to solve it, we just set each of your factors equal to 0 and solve from there. So I would have cosine theta equals 0, right? That's that one. And I'm going to set this equal to 0. Look here, guys. I'm going to not show all the work. I would add 1 and divide by 2, right? Add 1 to the other side, divide by 2. That'd be 1/2. Get that, Evan? Now I need to know my unit circle. So when I hear cosine being 0, it's making me think of my quadrantals. Write it, don't write it, doesn't matter to me. But you should know that cosine is your x values, and cosine is 0, up at pi over 2, and down at 3 pi over 2. Right? And what's the denominator when cosine is 1/2. 3. And cosine is positive in 1 and 4. 1 and 4. That would be that one. Remember, the order doesn't matter as long as all 4 are there. There's pi over 2, 3 pi over 2, pi over 2, 5 pi over 3. Right, so those are your last 3 problems that we'll do tomorrow. We're starting with number 4, which is the calculator stuff. Okay. Although number 4 you don't even need a calculator. Another solving. So remember, that last one, we solved an equation. I just want to know what was on the unit circle. That's why we're just looking at quadrants 1 through 4, answered it, done. That's what that meant. This one is saying solve and find all. General means all. And I'll go back to what that means in a second. So let's take this equation and solve it. Square root of 3 tan x plus 1 equals 0. Right, guys, you got to get tan x by itself. You don't need to show all the steps. You subtract 1, divide by the square root of 3. Remember, to solve a trigonometric equation, you want the trig function and its variable by itself on one side. So you just use your regular old algebra skills to make that happen. Now, smart test taker says, I already know this is a denominator of 6 because look at all my choices. But I told you would see this one a lot. You could just memorize it, or of course we do know how to get that radical out of the denominator. Okay. So tan x equals that. So x is what? Where is tan negative? Well, we already know the denominator is 6, right? There's 2 of them where tan is negative, and that would be quadrant 2 and quadrant 4. So quadrant 2, I would subtract 1 from my denominator, and in quadrant 4, at 5, I go to 7 and 11. And looking at my choices, they didn't offer me 11 pi over 6. They only offered me the 5 pi over 6. So I know it's not A or B, right? We know it's not A or B because that's quadrant 1. How do we know the difference between these two? Because think about it. You got 5 pi over 6, you're super proud of yourself, and then you're like, wait a second, why are there 2 answers with 5 pi over 6? Well, the difference in those problems is the period, okay? So what we want is all the solutions. So what is the period of tan? Pi. That's why it's not this one. It's this one. You want pi. So what this means is we can add any number of pi's to this. We can do positive n's or negative n's. N belongs to the set of all integers. That's what that means. You can put a positive number or a negative number there. Put a 1 there. We go 1n from 5 pi over 6. We land at 11 pi over 6. You do negative 1. Go backwards and go into negative angles. But that's a way of answering all of the solutions by using that. Okay. Number 5. K can't be 0 and k is greater than 0. What is the range of this cosecant function? Now notice there's a k in front of the word cosecant after the equal sign. Normally that's a number, right? It's called your amplitude. 5, 1/2, whatever. So we know k can't be 0, and they're saying k is greater than 0, meaning there's no flip. It just is the regular old cosecant graph, which is really the graph of sine with a little sparkle added onto it. Again, I like to sketch a graph, up to you. So if I sketch a graph of sine, okay, that's middle, up, middle, down, middle, right? That's sine. And since it's cosecant, what I would next do is put my asymptotes there, which I'm not going to bother with right now, so I'm not wasting time with that. But what I do care about is how high the graph goes and how low the graph goes, because that's what range means. What are all the y values I use? And if you look, all of the choices have a k in them. Well, because that's your amplitude. K can be any number. Who cares? We're saying this is k. Put a 4 there, then you'd call that 4. Put a 10 there. That makes k 10. Who cares? And then down here would be negative k, right? So whatever your amplitude is, that's where your highest and lowest point. That's my max and your min. But because it's cosecant, we have those u's going off of that. So we are going to answer this with interval notation. Your range is from negative infinity to negative k. Then you skip over a chunk of the graph, right? There's no points, y values used in the middle here. Then we go from k to infinity. That means there's going to be a union symbol. Because we don't use from here to here. We use all of these, skip all of these. Now you have to decide which one of these you use. One has parentheses, one has brackets. Brackets, because this point, whatever it is, let's call it 4, which makes this negative 4, right? Pretend it's 4. You do have a point at 4. That's how you knew where to put that number, right? When you graph sine, you went middle up to 4, middle down to 4. That is an actual point. So you would include that k value, brackets. Okay. Number 6 is where you really have to be careful how you put this in your calculator. Those people that don't pay attention, clear your RAM for a second. Those people that don't pay attention, want to jump in later in the problem, aren't listening, doing their own thing, thinking that they can get ahead of me, are the ones that interrupt their neighbor who's trying to listen to me and say, can you help me fix this? So don't be that neighbor. Do this one with me, okay? I'm telling you, this is on the test mark. This question, just with different numbers. This same question, you have to do tomorrow by yourself, so pay attention. All right, the monthly profits, T in thousands of dollars at a winter ski resort are approximated by this function down here, where T is time in months with T equals 1 response in January. Determine time from 0 to 12, it's a year, right, where profits are $100,000 or more. So what we're going to be doing is doing a Y1 situation. This would be Y1. We're going to put that in our calculator. And we're going to put a Y2 in there of Y equals 100. Okay, so I'll come back to that in a second. The reason I'm using 100 instead of 100,000 is because it said in thousands of dollars. These have to match up. Look, 87.5 and 54.25 are already moved into the smaller number, okay? If these are in these are less than 100, if you put 100,000 here, they wouldn't match up. So it said in thousands of dollars, so that's $100,000, okay? And the reason we're doing this is because this is an inequality. We're going to see where our profit goes above 100,000, and we'll answer that down here. The part that's tricky about this is putting it in the calculator, okay? So let's start typing in our Y1, 87.5 plus 54.25 cosine. It opens your parentheses for you. But guys, there is multiplication, subtraction, division, all going on in this parentheses. You have to put your numerator in its own separate set of parentheses. You are going to do a double parentheses here. If you don't, it's not going to work. And I'm not going to tell you that tomorrow. You have to know that. Second pi, x of pi x, minus 4. That's the end of my parentheses. My numerator, right? And my parentheses. Right? That's my numerator. Divided by 6. Close them. You could close them twice, but you don't need to. And then y equals 100. Now, I'm not even going to bother graphing this yet because I already know one thing they told me to change is my x-axis should go from 0 to 12. Okay, so I'm going to go to Window, change that 0 to 12. And I have a y value at 100. Right now, it only goes up to 10. So I need to be more than 100 at least, right? So I'm going to just put in 150 as my max. Now let's see what it looks like. That curvy graph, that's my profits. The blue curvy cosine graph, up, middle, down, middle, up, that represents my profits. The red line, the horizontal line, is where 100,000 is in those profits. When are we above 100,000? Look, we're above the red line from here to here, right? This is all above. And then not in here, and then here to here. So I need to find the intersection of these points here. So second, calc 5, enter, 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 just gave me my first one. 3.8. Do it again, second calc, intersect, I'm going to arrow over. enter, 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 get my second intersection. So those are the two places where we intersect. And to answer the question, it's what I have in blue here, right? Where am I above that horizontal line? From 0 to this intersection point, then again from this intersection point to 12, right? This is 0 to 12. So that would be answer B. Yeah. No. What makes you think it would be that answer because it's cosine? Well, what if it said, well, I mean, I would never just make an assumption like that. I mean, what if it says less than, then it would be it would be those. If you want to make I'm going to say, yes, if you want to make a guess, that's fine. I just wouldn't advise it. I would want to look at the graph. I know what you're saying, but yeah, I mean, if you want to risk that, that's fine. I would never, but if you feel pretty confident that it's always going to happen like that, then, I mean, I don't not ask you guys to show work, so, okay. All right, number 7. Paying attention? Function f is given. Function g is given. What are the zeros of g on this part of the x-axis? Okay, so all I want to know is where does this function touch the x-axis? That's what zeros are. What are the solutions? Where the x-axis is. Okay, so look, I have g is 2 times f of x. 2 times f of x. So I'm going to do 2. I always write right here and I never have enough room because I just write so good. Let me go here. G of x is 2, right, times f of x. F of x is right here. Sine of 2.5x plus 0.25. Notice the double parentheses there. So that was this, plus 0.35. So f of x is all of this. You see, I just plugged it right into the equation. So I'm going to graph this and find the zeros. So clearing my RAM, y equals 2. Open parentheses, sine, it open parentheses for me, 2.5x plus 0.25, close, close, plus 0.3. Oops, I forgot to change my window. See, I don't want all of that. I just want from 0 to pi. So I go back to my window, 0, pi. Look at it again. Much better. Zeros are your x-intercepts. But guys, where we do min, max, intersect, there's a 0 button. Just use that. Right? 2. It's asking for left bound, right bound, like all of these do. Enter. And I get 1.22. So I wrote that down. And then I find my other one. Second, 0 over. Enter. Enter, enter, and I get 2.34. So those are my zeros, which is C. Not 2 equations, guys. It just asked for what are the zeros of G. It didn't ask for the solution of G. It just said what are the zeros of G. So that's the only one we put in. Okay. Number 8, solving an inequality. Guys, we've been solving equations in our calculator a ton. We learned how to solve inequalities. Same exact thing. We have y1 and y2, left side, right side. Where do they intersect? Those are the solutions. Now this is taking it one step further and saying where is the left-hand side above the right-hand side? That's fine. That's just as easy, pretty much. Clear your RAM. Type them in. y1 is one of the sides. Pi over 3 is a fraction. I'm going to put it in parentheses. And then the other side is sine x. Just exactly what you see there. Bless you. It gives you an interval of 0 to 2 pi. 0 to pi. Here, Evan. You're just typing that in, and that is what you see right here. That's on one side, that's on the other. Remember, fractions get put in parentheses in these calculators. Okay? Change your window to 0 to 2 pi, and let's see what's going on. Now remember, when I graph it, I have two different colors. When you hit graph on those calculators, you need to know which one's the first one and which one's the second one. So y1 is being graphed right now. y2 is that one. Where is blue above red? Well, if it's hard to tell on your calculators, especially yours, you can go back to your window and close in on your y's. Like maybe do -5 to 5, so it zooms in a little bit more. So you can see much better where the blue is above the red. It's from here to here, right there, on that part of the x-axis, that interval, from here to here, blue is above red. So you know it's not going to have a union. Union is where it's like this part, then we move over, and then this part. It's just from here to here. So I'm going to easily say it can't be these two. And guys, you can find the intersections, but you know it's one of these two answers. Do I really have to find the intersections? You can, go ahead, but you're going to get 209 and 5.24, right? How do you know which one to use, though? The one that has brackets, because remember, if it's a greater than or equal to sign, you have to use brackets. If it had this symbol, it would have been parentheses. So you didn't even have to find intersection on that. If you understand interval notation, you know it couldn't have been these two. Okay? But if you did do intersection, you'd get those two numbers. All right, number 7's a pain, or number 9, our last one of these, is kind of a pain, so clear your RAM again. There's a lot going on in this problem of like prior knowledge. Okay, so let me read. A 10-year study was conducted on the population of a herd of deer, T, with respect to time, T in years. Total number of deer over time can be represented by this function. Okay, so notice there's that T population. They're using X. X is what we type in our calculator, but X is T. Time is your X-axis. Doesn't matter what letter. Okay, so we're going to put that in our calculator, and then we're going to figure out which one of these is true. So 500 sine, parentheses open. Instead of doing 1/4 and having to put 1/4 in parentheses, I'm going to use 0.25. Same thing. Parentheses. Pi x minus 2. Double parentheses, right? If you have a set of parentheses within parentheses, you have to close them both. Plus 4,000. I'm not even going to bother trying to graph this yet. I definitely have to change my window. Now, on some of them it said from this to this. This just said a 10-year study. So that would mean 0 to 10. 10 years. And guys, we have a midline of 4,000. That's the middle of the graph. And then it goes up from there, 500. Okay, that's your amplitude, right? So we're at least at 4,500. So I'm going to go to Y max and put in like 5,000. And I'm going to graph it. Now, I'm going to show you guys a little trick. If you go put your midline in as a second equation, okay, put the midline in, what that does is shows you the middle of the graph. What is the middle of the graph good for? It tells you where we change concavity. It's your points of inflection, and that's going to help us in a second. So, in other words, we are increasing, decreasing, increasing, right? Watch me do this again. Watch, you gotta watch. We are increasing, decreasing, increasing, okay? We're concave down, concave up, concave down. Wherever we are concave down, that's a decreasing rate. Wherever we are concave up, that's an increasing rate. Remember, the rate of change of D is decrease, down, decreasing, all that. So that's just a helpful hint. By putting that midline in as a second graph, it gives you some references that are going to help you with this problem. So the first thing is minimum number of deer in the herd occurs between 5 and 6 years. Minimum. That's this point here, right? Guess what? That's a button in calc. Minimum. Let's find the minimum on this graph. So we just want to get on either, it's a left bound, right bound, same thing we do with zeros, intersection. We've done all of these a million times. Enter. enter, enter. So we have a minimum at 6.63. Our minimum is at 6.63. I rounded it. This is just my own notation. Is that between 5 and 6? Certainly not. That's in the 7th year, 6 plus some more. Okay? Part B, the deer population is decreasing at a decreasing rate. It's going down and a concave down section of the graph, which would be right here. So that would be, again, watch my pencil, going down, decreasing at a decreasing rate would be from here to here. That's where we are concave down. That's where that midline helps me see. So if I see what this point is and this point is, I can see, is it 2.64 and 4.64? That's intersection. Or, well, first it's going to be max, right? I want the max. So my max is, go over there. What I'm hoping it is 2.64. Enter, 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 and it is. So yes, we have a max at 2.64. That's that number there. And if we do the intersection here at the midline, that's where it would change from decreasing to increasing. That's what we're wondering. If we get 4.64 right there, we know we found our answer. So I'm going to use intersection. I can really hit it. Enter, enter, enter. And yep, I get 4.64. So that is my solution. Just real quick though, let's kind of just talk about these. Increasing at a decreasing rate would be this part of the graph, right? Right here. And that happens in two different places. It happens here and here. How would I know which one to check? Well, it's definitely not 0. It's 6.6. It must be this one. And if you checked that, if you checked right here to there, it's not these numbers. Can't be. We already know this is 6.64. And changes from decreasing to increasing. Look, 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 look. Decreasing, we change to increasing right here. We already know that number is 6.64. That's that minimum. So that's not true. It happens at 6.63. We already found it. That's that minimum. So it can't be that one. There's a lot going on in that problem. You really have to know what that vocabulary means. And we've talked about it all year. It's never going away. Last one, FRQ. Even though this looks gnarly, it's not. You've done it before. Muscle memory, this problem. Clear your RAM. And it says, a table below shows the number of hours of daylight during 2022 for theme parks near Orlando, Florida. Instead of giving us an equation, it's giving us XY's data. And it asks for a regression, a sinusoidal regression. Whenever you hear regression, what button do we go to? Stat. Enter. And this is what takes the longest on this problem, so start doing it. My months are L1, my hours are L2. Obviously you can't put in January, so you're doing 1 through 12. So you should be typing these in now, so you're not behind. I see some of you just watching. Good luck tomorrow. Where do we go next? Muscle memory. Where do we always go right after we type all those in? Not calc. Stat again, then over to calc. And this is the only new part. Which one are we using? We've done a whole bunch of them in here. We need to find sign. So you can scroll through. I recommend going up to get to the bottom of the list. and you'll see it there on your screen. It's SIN, sine red, sinusoidal red regression. So that's the one I want. And just like before, go to where you store it, alpha trace, enter, enter, enter. And there it is. It gives you the equation, and it tells you what each of the variables are. So you would type those. It's 4 points for being able to put all that in, get your equation, and round correctly to 3 decimal places. Okay? Rounding matters, got to round correctly. Okay, part B asks, what is the midline? Well, guys, we should know that's D by now, right? That's a point right there, just being able to say your midline is y equals 12.072, right here. But another point to explain the meaning. Remember, in these FRQs, we're not caring about vocab, we're not caring about vocab, yes, but we don't care about grammar or spelling or anything like that. But can you tell me, in your own words, what the midline means? And so think about it. It's the middle of your data. It's the middle. And we don't say middle. Like if that's the middle of the number of hours of daylight. It's the average. That's the word we would use. Okay. So the midline of the regression, the average number of hours of day, and then like what is this whole thing about? I sometimes have to go back and read the question. It's the number of hours of daylight during 2022. So that's where I got the midline is the average number of hours of daylight over the 12-month period is 12.072. Midline, middle, average, halfway. Okay. Part C is AROC, or slope, between June and July. So just those 2 months. What's the rate of change? What's the slope? Guys, you've been doing slopes since you were just little babies. Change in Y over change in X's. June and July, gotta go back up to the chart and see. June and July. January, February, March, April, May. June is 6, July is 7. Those are the 2 X values, and then the Y values are whatever the Y values are in the chart. So, change in Y's over your change in X's, you get 0.08 hours of daylight per month. That's a point. You can get 2 more points for explaining it. And I'm telling you exactly how to get your 2 points here. What does that mean? From June to July, we have an increase, right, because it's positive. This is an increase of 0.0 hours per month from the month of June to July. So in between that much time, we gain 0.08 hours of daylight. But guys, we don't speak in that kind of language. I don't say it's 0.08 more hours of daylight. What does that mean? Well, how many minutes is that of an hour? Well, 60 minutes in an hour, so I just did 60 times 0.08. I want to see both numbers in your sentence somewhere. Of course, my sentences are not the only way you can write them. As long as you can convey the information somehow, that's what matters. Okay? So 0.08 hours per month is 4.8 minutes that we increased from June to July. That's what that means. If it were a negative number, we would have been decreasing by that much. What did she have you in there for? Okay. Mr. 18 class. Okay. Cut out. asked her not to take kids out of my class. I mean, it's not your fault. I was just doing what she told me to do. She should not be pulling kids out of my class. I'm not okay. All right. So, guys, that's the test. All right. A lot of old material too. Knowing how to put it in your calculator. Hopefully, you did those with me, or at least you understand how to do them. All right. We have a few minutes left, like a good amount actually, like 10 minutes left. So if somebody needs me to go over one more thing with them or something, I will. Let me just end my recording and I'll come see you.